Is it ultraviolet, the next one, after radio waves? What's the second one? Yes, Rancap.
Microwaves po.
Microwaves. Okay, the third one, Jake. Jake?
I don't
Don't memorize. Radio waves, microwaves. What's the third one? Yes, Antoinette.
Infrared.
Infrared. Is it infrared?
Yes.
Okay, very good. Infrared. The fourth one, Abby. What's the fourth one?
Visible light.
Visible light. After visible light, next is Kevin.
ultraviolet rays po.
Ultraviolet rays. Then after that ultraviolet rays, Eric Jacob, what's the next one?
X-rays po.
X-rays. And the last one, which has the high frequency and high energy, Akira?
Gamma rays po.
Okay, the gamma rays. Okay, so again, radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays, and gamma rays. Isn't it you have the code of that one? Remember? Your mnemonic something? Oh, you should remember that one. Okay? So, let us now proceed with the effects of the electromagnetic radiation. Okay, actually the one here in my PowerPoint presentation, it's the computation if I'm not mistaken. But before that, let's talk about the effects of electromagnetic radiation. So what are the effects of the electromagnetic radiation? Can you give me? Electromagnetic radiation has the harmful effect as well as there is also a beneficial effects of this electromagnetic radiation. No? So we have the good side and or the advantages and disadvantages of the electromagnetic spectrum. So let us go first with the beneficial effects of this electromagnetic radiation. What do you think are the beneficial effects of this electromagnetic radiation? Yes, Kevin. Let's go first with the advantages, the beneficial effects of electromagnetic radiation or electromagnetic spectrum. Benefits in technology. Nathaniel, would you explain more with the benefits of technology?
Due to po discovering po the electromagnetic spectrum po, we are able to have such technologies po sa cellphone, chemotherapy po, X-rays because we discovered it po.
Very good, no? So let's give our virtual claps to Nathaniel. Because of this technology, no, this is one of the useful effects of this electromagnetic radiation. That's why we come up with the microwaves, no? The chemotherapy we're using because of that gamma rays. Okay, your cell phone, your laptops, that's the one that we're using. Okay, it's because of this electromagnetic waves. What else? Yes, Chanel, you want to say something?
I know po. Sorry po, sir.
Okay. John Marlon Labares.
Again, sir.
John Marlon, would you mind to give us some of the beneficial effects of this electromagnetic radiation?
Ano po, sir? The X-rays po, ganun. And the uses of phones po, ganun.
Okay, the X-rays so that we can see those fractures in our bones, no? What else? Any other advantages of this electromagnetic? Yes, Carl Leal. Carl, what do you think are the advantages of electromagnetic spectrum? With that in your screen, no, the radio waves, the microwaves, infrared, ultraviolet rays, visible light, X-rays, gamma rays, what are the advantages? Carl, are you hearing me?
Yes, I hear you, but
Okay.
I can't think of an answer yet, sir.
Okay, later on, I'll go back to you. May I hear the voice of Aldea? Aldea, what do you think are the advantages of this electromagnetic spectrum?
It is also in the medical field, the radio frequency ablation po, which is, or in short, RFA. And it uses imaging technique like the ones for X-ray and uses heat to shrink the sizes of tumors, cancer cells, something like that.
Very good. So that's also an example, no? So to eliminate those cancerous growths, no, especially the tumors, they're removing that one. Okay. So by doing the laser sometimes, no. With this, what else, Roy? Any other?
Sir, I'm thinking pa po.
Still thinking, Sarah.
Me po?
Yes po, Sarah Denise, class number 42.
For the visible light po, because of visible light, of course, we have the light bulb, so we are able to see in the dark po.
Yes, okay. And remember the money, isn't it? If you have the store, we can now check the money whether if it is fake or not because of that light. You remember the blue light? Isn't it? If you will put the money there, you can check already if the money is fake or not. Okay, what else? Someone asked raising their hand a while ago. Who's that one? Yes, Akira.
Sir, from the violet rays po, moderate exposure to UV rays, no, as we all know po, sun is a good source of vitamin D, so we can get healthy from that po, or we can get the vitamin D from the sun po.
Correct, Akira. Very good, no? So we can get vitamin D with that sunlight. Okay, especially if you're having cup, no? Sometimes our parents telling us, you go out, no? Just remove your upper shirt, then just go under the sun, no? Go under the sun. Okay, what else? So actually a lot, no? A lot of beneficial effects of these electromagnetics. Nowadays, we can contact with our relatives, no? Especially in other country. No, we can talk already because of those cell phones, because of these laptops. So those are the advantages. But of course, with that advantages, there is also harmful effect of this electromagnetic radiation if it is what? Overuse. Okay? So, for example, we said, just like what Akira said a while ago, if we are under the sun, we can get vitamin D, especially if we are from 7:30 to 8 o'clock. But if too much exposure with the sunlight, no, sometimes what we are feeling is we're having sunburn already. Isn't it? No? Because too much exposure with the sunlight. So it's not good if it is really excess. Okay? Sabi nga sa Tagalog, dapat tama lang. No? It will not be excess, it will not be lacking. As in, right way of usage. No? Okay? So this time, let's proceed already with the harmful effect of this electromagnetic radiation. What do you think is the harmful effect of this electromagnetic radiation in the living organisms? We are part of the living organisms, isn't it? So what do you think are the harmful effects? Anyone? Yes, Pawi. Okay, so it can damage your DNA, no? It can damage your skin cells. According to Nathaniel, radiation we can get from that too much exposure with the electromagnetic radiation, no? Okay, what else? Huh? Any other with regards to the living organisms? Isn't it? If the human being are overexposure with the sunlight, sometimes they're having heat stroke already aside from the skin cancer. Isn't it? Why? Because they are lacking of waters inside their bodies. That's why they're feeling like that. Okay? So what else? Aside from that one? Anyone from the group? Yes, Cyril. Na class number 37. Hello, Sai. Cannot hear
I
you.
can take hand of anything po.
Okay, any other? What else? Gian, Biliana.
From overexposure to radiations like this from electromagnetic radiation, it can cause cell mutation.
Gian, excuse me, I cannot understand properly.
Here po, you can understand that po.
There, it's clear.
Overexposure of electromagnetic radiations can cause cell mutations and um, no, the changing of heat of body tissues, which may lead to not only cancer but also other severe illnesses.
Okay, thank you so much, Gian. What else? Any other additional? Renz Santos. Renz, let's go with the harmful effect of electromagnetic radiation.
Sir, I don't know pa po.
What I don't have? My goodness, it seems that you don't know the topic. My God, this is our first day in meeting. What is happening if you are too much exposure using your cell phone? What is happening to you, Renz? Hello, Renz. Huh? Okay,
Your
okay.
eyes.
Troy, overuse of gadgets that can damage our eye vision. Correct, isn't it? That's sometimes you have to wear the eyeglasses which have the anti-radiation or anti-radiation. Isn't it? If it is too much exposure with this laptop, sometimes your eyes is crying already, but you're not crying. No? With water already. You can feel that one. And sometimes you will feel dizzy already if you are overexposure with your laptops. Okay, that's one of the example. What else? Huh? There are some studies in which if you are sleeping, make it sure that your cell phone is really far from you. No, because radiation you can get and it might affect your thinking or something or with regards to your body. Okay, so that's the one. Any other effects or harmful effects of this electromagnetic radiation? Huh? You are prone with your gadgets, no? And sometimes some of you, for example, Roy is keep on going out for biking and then under the sun. What is the one that you're feeling if it is like that, Roy? Huh? Wala lang.
Headache po, sir.
Headaches sometimes, no? Okay? So because too much exposure with the sunlight. What else? Any other? Yes, Denzel. Denzel, can you give me some harmful effects of this radiation? Ayun.
What kind? What kind po? What kind? From the cell phone po?
We're talking about the harmful effect of radiation.
Radiation sickness po.
Can you elaborate more with your answer, Denzel? What kind of radiation sickness?
The kind po that Marie Curie died from because she exposed herself because she studied radiation a lot.
Okay, any other? Francis, Carlo.
I think po for the gamma po, it is used po to kill bacteria po, but overexposure daw po can also damage the cells po.
Okay, thank you so much, Francis. Yes, Akira.
Prolonged UV exposure po can cause, I think, can cause skin cancer, and it can also cause skin aging. Like that po.
Okay, so those are the example, no? Okay, any other? No more? Yes, Micaela, katam ko. What else?
Ano po, it causes cancer like that po and headaches po. Yun lang po.
Okay, causes cancer and headaches. Okay, Kate Ranyola.
In terms of chemotherapy, although it kills tumors and cancer cells, it also kills the good cells that we have.
Okay, thank you so much. So those are the beneficial and harmful effects of the electromagnetic radiation. No? Mga kapatid, basa-basa po tayo. I know that we have a long weekend last time. But this time, try to remember all the things that we had last time with regards to electromagnetic radiation. No? So we're done with the electromagnetic radiation. This time, no, let's proceed with this computation already. So in electromagnetic radiation, remember, largest wavelength, okay, to shortest wavelength. If it is largest wavelength, meaning to say it has a low frequency, and highest frequency, meaning to say it has a shortest wavelength. For shortest wavelength, it has a low or high frequency rather. Okay? Then, of course, if it is lowest frequency or low frequency, the energy is also low, no? Or the energy is least, okay? While on the other hand, if it is high frequency, then energy also is high in frequency. So remember, yes, Carl? You're fixing your hair in front of the camera. So remember, if high frequency, then energy is also high. And if the frequency is low, then energy is low also. Okay, so try to remember that one, ha? So we have here the formula regarding with the wave period, no? So for the wave period, we have T is equivalent to 1 over the frequency. Or it can have it T is equivalent to wavelength over V. So this is the one. Okay? So, and the unit per wave period is S or seconds. Okay? So, what about the unit for the velocity? So, if you're talking about the lights or something or wave, so here, because it's the same formula with the light. So, V is equivalent to frequency times the wavelength. Okay? So, frequency also can have this one, 1 over T, where T is the wave or the period. Okay? So that's the formula. Do the screenshots because we will do an activity about this one. Okay? We're going to solve some problem. I hope you have your calculator with you. So by the way, velocity, the unit for velocity is meters per second. For the frequency, what is the unit per frequency? The unit per frequency is hertz. Okay? And what is hertz? That will be Hz. Okay? This one. So that will be hertz. Okay? That will be the unit for frequency. Okay? Then meters per seconds, that will be the unit for velocity. Okay? Then, aside from that one, for the wave period, that will be seconds is already given here. So let's try this first example. Violet light has a wavelength of 4.10 times 10 raised to negative 12 meters. What is the frequency? So how to compute that one? So you have your violet light, no, has a wavelength of 4.10 times 10 raised to negative 12 meter. What is the frequency? Okay, so going back with the formula, okay, what do you think is the formula that we will be using if the frequency is given? Huh? Okay, so please wait. I'll use my other camera. So as you can see here, no, the given, I don't cameras already. Okay, so the given in the, you can see my handwriting. It's visible. I cannot find my pencil pen. I hope it's working.
Yes, po, sir. Yes, po, sir. Visible po.
Thank you so much. Okay, so what are the given in the formula? We have the wavelength, no? Let's put it as lambda. By the way, this symbol is what we call lambda. That will be 4.10 times 10 raised to negative 12 meters. Okay, so that is the one. Then we're going to find the frequency. This is the unknown, no? The frequency. It's written in problem number 1 that violet light has a wavelength of 4.10 times 10 raised to negative 12 meters. Since we're talking about violet light, or we're talking about light, then the velocity will be equivalent to 3.0 times 10 raised to 8 meters per second, since we're talking about the light, because the unit for light is what? Or the value of light, if it is talking about this one, no, that is 3.0 times 10 raised to 8, or that is what we call the speed of light. So the speed of light is equivalent to 3.0 times 10 raised to 8 meters per seconds. So that's the value. Now, you have already the wavelength, you have already the velocity. Okay? Because we cannot use this FO is equivalent to 1 over T, because T is the wave period. So we don't have that one, no? Since the given is only wavelength. Okay, that is not wavelength. We cannot use that one. Okay, so this is the one that we will use. So what formula we will use? Huh? Based on the given problem here, or these are the given, isn't it this formula we will use? So V is equivalent to, V is equivalent to F times the lambda. But you need to derive this formula. Okay, and how to derive that one? Huh? Since you're looking for F, then you have to what? Divided by both side by lambda. So cancel this one and cancel this one. Then you have already F is equivalent to V over the wavelength. So this will be your formula. Okay? So since we have already the formula, what we will do is to what? Huh? What we will do if we have already formula? Can we solve already? Can we solve already? Okay, let's substitute already. So what is V? V is 3.0 times 10 raised to 8 meters per seconds all over your 4.10 times 10 raised to negative 12 meters. So cancel this one, then we can have the 1 over S. Okay? Then, what's the value for our frequency? Can you solve that one? 3.0 times 10 raised to 8 divided by 4.10 times 10 raised to negative 12. The answer is, what's the answer? You have your calculator. Oy, what happened? Let's wait. So what's the answer, guys? You can type your answer in the chat box. What's the answer graded? Anyone who could give me the answer or type in the chat box the answer? You have your calculator, grade 10. Go, type your answer in the chat box. If you will not put your answer, the other 7.2 seconds. Yes, you can round up the hundreds place, no? (7.32 seconds), and then the other is with exponent. What happened to the others? Okay, so I think some of you got the answer, but only few are putting the answer in the chat box. 7.32. How did you get the 7.32 seconds? Huh? Rounded up po. The 7.32 is rounded up already. Without exponent? Nathaniel, without exponent? Is that question? Or you're telling to me the answer? Mackenzie, how did you get the 7.32 seconds? Mackenzie?
Sir, what we did po is, the answer is 7.31, 1773, 171. After that is P1, there's 7, we rounded up.
Yeah, but you did not notice the exponent? Okay, so if you will put this one in the calculator, your answer will be 7.32 times 10 raised to 19 per seconds, or that 1 per seconds is equivalent to the same as this one, 7.32 times 10 raised to 19 hertz. So this will be your answer, since frequency is hertz. Okay? Huh? I don't know what happened to you. Why did you get only 7.32 and then you did not put the exponent? No? Okay, let's try another problem. Let's try this one. Okay? So we're talking again green lights. We're talking about lights, no? Green lights have a frequency of 6.01 times 10 raised to 14 hertz. What is the wavelength? Okay, so this time they're asking about the wavelength. Okay, let's find the given in problem number 2. What are the given in problem number 2? Can you give me? Yes, Eric, Jacob. What are the given in problem number 2?
6.01 times 10 powered by 14 hertz.
Times 10 raised to 14 hertz. What else, Eric? We're talking about lights. Are we going to use the 3.0?
Yes po.
Yes po. It seems that you're not, okay, we have 3.0 times 10 raised to 8 meters per second. So what is the one that we're looking for? Problem number 2, Kevin. We're looking for Kevin, what are we going to find in problem number 2?
Wavelength po, sir.
Wavelength. Okay. So we're looking for the wavelength. So what's the formula in order to get the wavelength? Isn't it? We have the general formula. B is equivalent to frequency times the wavelength. So this is the general formula. So what we will do now in order for us to derive, divided by both sides by what? Anyone from the group?
Divide both sides by the frequency po.
Very good. Divide both sides by frequency. So we can cancel frequency here and cancel frequency here. Then we can have already lambda or wavelength is equivalent to V over F. Okay? So since you have already this kind of formula, we can now substitute the value. So what we will do now is to write what is our V? We have 3.0 times 10 raised to 8 meters per second divided by our frequency, which is equivalent to 6.01 times 10 raised to 14 Teacher, what about hertz? Then we can express that one per seconds. Okay? That's the one. Okay? So we can cancel seconds here and cancel seconds here. Then we can now compute for our wavelength. So, putting in the calculator, equating that one, what is your answer? Hmm? You can put your answer in the chat box. The answer is what is the answer if you will put that one? Oy. Oops, don't forget the unit. What's the unit, Gabero? Okay, so the correct answer is you have your 4.99, okay, times 10 raised to negative 7 meters. So this will be your answer for your wavelength. Okay, thank you so much for those who answered. So Jake, Abby, okay, Abigail, we have Sarah, John Marlon, Gab Biteng, Pawi, Eric, Jacob, Gian, Maynard, Rancap, Mambat, Ranyola, and Francis Gabero. Thank you so much. Okay, we have already Antoinette, Madeline, Akira, and Niels. Thank you so much for those who answered in the chat box. No? Now, let's go already with our third problem. Let's try this third problem. It's written here, calculate the wavelength of radiation with a frequency of 8.0 times 10 raised to 14 hertz. Okay? It seems it's the same. No, not. Only the exponent. Okay? So you need to calculate the wavelength. You're looking again for the wavelength. Okay? So what are the given in the problem number 3? May I hear the voice of Lakatan? Hello,
Hello, sir.
Lakatan.
Can you hear me po?
Ah?
Can you hear me po, sir?
Yes.
The frequency po is 8.0 times 10 raised to 14.
Raised to 14 hertz.
Then,
Then,
the V po is
B. What is
2.0.
B, Lakatan?
I forgot po, sir.
The B is velocity or the speed of light, which is equivalent to
Ay,
the value.
3.0 times 10 raised to 8 ms.
Meters per seconds, no? Okay? So, and we're looking for what? Maria Ana, what is the one that we're looking for?
Sir, we're looking for the wavelength po.
Wavelength. And what's the formula for wavelength?
It's ano po, V over frequency po.
Come again?
Velocity over frequency po.
Velocity over frequency. Very good. So, what we will do is to substitute already. So, what is our V? We have 3.0 times 10 raised to 8 meters per second all over 8.0 times 10 raised to 14. Since it's hertz, then we can express this hertz into 1 over S so that we can cancel S and cancel this one. Then our wavelength is what? What is the value of our wavelength? I love calculator. You can type it in the calculator or type it in the chat box rather. Okay. Yeah, I can see the answer of wow, Gabero, very good in computing, ha? Okay, very fast. So the correct answer is, ay, hala, kulang. What is that? Okay. You're lacking of units. Okay. Correct. Okay. So the correct answer is, because you only have one number. Okay. So 2 decimal, ha? So the correct answer is Oh, very good. They're very active this time, ah. So 3.75 upon checking with my calculator as well times 10 raised to negative 7 meters. That will be our wavelength. Okay? Thank you so much, Jake, Bernadette, Abby, Jello, Nathaniel, Antoinette, Pawi, Joshua, Madrin, then Gian, Francis, Carlos, Sarah, Pawi, Kate, who else? Gab Biteng, Cyril, John Marlon, Aldea, Francis Gabero, congratulations. Uy, there, Maria Ana, congratulations. I hope that you're computing also, ha, not to copy the one in the chat box if they're asking, no? So that you can follow. Can we have another problem? Let us try this one. Problem number 4. Okay, it's written here. A wave has a frequency of 50 hertz and a wavelength of 10 meter. What is the speed of wave? Or what is the speed of wave? So you have already 50 hertz and 10 meters. So let's try. You compute already. Let us see if you can get already this one. Okay, so frequency is 50 hertz and your wavelength is 10 meter. So what is the speed of wave? Wow. Okay, we have Kita Nyola, which has the answer 500 meters per seconds. And the others also. Okay. Let's wait for the others. Let me hear the voice of Jake. Oh, Jake, bawi tayo. Ha? Problem number 4. What are the given?
The frequency is 50 hertz and the wavelength is 10 meters.
Okay, 10 meters. What's the one that we're looking? The
The
speed.
velocity.
Or velocity. And what's the formula for velocity?
Frequency times wavelength.
Okay, we have frequency times wavelength. Substituting that one, okay, we have 50 hertz. So in order to us to express this hertz, that will be 1 per second. Multiply with 10 meters. Then we can have it, what? What's your answer? 500. Yes, that's the speed. 500 meters per seconds. Okay po? Huh? Question about this one. Is it clear already? Huh? Okay, let's try another problem, ha? Okay, what about this one? Oh, try to answer. A wave has a frequency of 5 hertz and a speed of 25 meters per second. What is the wavelength of the wave? Okay, compute. You're asking about the wavelength, ha? Okay, let us see. You have already the answer. Five meter. Ah, very good, very good. Okay. Let me hear the voice of Maynard. Maynard, would you mind to explain your answer? How did you get this 5 meters?
uh, with the
Yeah.
with the velocity over frequency, I divided the frequency and the 10 meters. I 25 divided by 5, it will be 5 meters.
Then, Maynard, lower down your camera so that I can see you. What formula did you use, Maynard?
Wavelength equals velocity over frequency.
Velocity over frequency.
Frequency.
Okay, then substituting, what did you get?
25 over 5.
That
And
is?
then I divided it.
What's your answer?
5 meters.
Okay, that will be 5 meters. Thank you so much, Maynard. It seems that you're sleepy still. Huh? Okay, Maynard. Okay, next. Let's have another try. So, by the way, congratulations for those who answered 5 meters. Let me check. Maria Tabita, Eric Jacob, Carl Kevin, Maria Ana, Jello, Madeline, Maynard, Joshua, Jake, Abby, Francis, Carlos, Sarah, Gian, Kate Ranyola, Bernadette, Cyril, Pawi, Aldea, Antoinette, John Marlon, Gab, Nathaniel. Okay, thank you so much. No, I cannot see the others, ha? You're not putting your answer on the chat box, especially this off camera. Okay, Luis, Jordan Clyde, please, please, please. The answer is Uy. Is 20. 1 divided by 20. Mhm. It's okay, Nathaniel. Understand. Okay, so the correct answer is 0.05 seconds. Very good. Very good. 10A, ha? You're following. Okay, is it 0.005 or 0.005? I see. 1 divided by 20 is 0.005. Okay, yes. Thank you so much, Gian. Are you there? You corrected already yourself. 0.05 seconds. So, very good, no? So, next. I think I still have, no? I have a lot here, so that you can practice. Or no more. Congratulations. So, for 7 problems, I hope you get already, my dear people of the Philippines, no? Okay? Any question regarding with the computation? Ha? Let me know if you're having hard time with the computation. Ha? Who among you having hard time with the computation? Do I need to post this computation? Ha? I will post this one. Okay, this way. I'm having my battery low already with my laptop. Okay. So, sir, why are the two formulas wave period is depending on the given? Yes po, I don't understand po the first one. Anong first one, Carl? Actually, wait, last 10 minutes. Okay? They're asking for the last 10 minutes for the G Classroom or Gmeet. It depends on the given. Yes, Aldea, you're correct. No? It is depend on the given. For example, a while ago, in the last part of the problem, they're asking about the wave period, no? So since the given is only frequency, then what you will do is the wave period formula, which is 1 over f. On the other hand, for example, if the given is only the wavelength, and if it's not talking about the light, then you will not use that one. Instead, you will use the other one. Okay? So you have to check with this one. But if we're talking about light, then you will use the speed of light, which is equivalent to 3.0 times 10 raised to 8 meters per second. Okay? So madali lang naman yun i-memorize, no? Okay? So, yeah, Carl, what is the one that you are having problem? Violet lights problem. The one in the violet lights problem. The one in the violet lights problem, no? Because we use the formula V is equivalent to frequency times the wavelength. Since the given is wavelength. Okay? Oh, look at this one. I'm going to return again my other camera. This way. Video. Okay. So look at this one. This is the problem number 1. Okay. Hello, where's the camera? Is it working, the camera? You can see? Not. This way. Here we go. So a while ago in the problem, isn't it the given only is this part, no? The wavelength. Now, if you will try to look, we're getting to have the frequency. What's if the given, for example, if the given only is equivalent to 4.10 times 10 raised to negative 12 meters, if only this one is given and you're going to look for your frequency, do you think we can solve for this frequency using this given? Huh? What is the formula in the frequency a while ago? F is equivalent to, what's the formula per frequency? The other formula, not the one with the speed of light. F is equivalent to, hello?
Velocity and
No, not the other one. I think someone answered in the chat box a while ago. I did not because I returned the call. What is that one? What is the formula per frequency in the first one? 1 over T. Thank you so much. 1 over the wave period. Now, try to look at this one. This is only the given, and this is the formula per frequency. Do we have the wave period? Meron ba tayong given ito sa T? Then A. Wala. So now, you have to think for another one. Maybe the other one can be with the formula B is equivalent to F over the lambda. If you will derive this one, since you're getting the frequency, what's the one that we're looking? Yeah, frequency, then you need to divide it both side by lambda. Okay, cancel this one and cancel this one, then you can get this formula already. Okay, and then substitute the value of the V, which is, since we're talking about violet light, so we're talking about light, you can use the value of light, which is 3.0 times 10 raised to 8, no? The value is 3.0 times 10 raised to 8 meters per seconds. Okay, that's the one that you will use for the value of light. Plus the given, which is 4.10 times 10 raised to negative 12 meters, in order for you to compute the frequency. Okay, Carl? I hope it's clear. You get already? Okay, thank you so much. If you still have question, please let me know, ha? You can chat me personally so that I can give you more example. Okay, next meeting. Hi, we did not started with the what is this light? Okay, anyway, please, I know you have your laboratory manual. Get your laboratory manual, page 33 to 36. This will be your PETA, home lab. Okay, image formation by a plane mirror. Okay, individually this one you need a mirror which is the same size as the 1/2 crosswise of your short band paper. That's the size of the mirror so that you can proceed with this activity. Okay? I'll post this one in the G Classroom. Okay? I'll give you time to do this one. Okay? You will do the A and letter B and please answer the report sheet on page 35 to 36. Okay? That will be in the lab manual, ha? This one po. Okay? But if who among you have the book already of 10A? No books yet. Who among you? Gian, no books yet with Science 10. Rancap. So I'm going to post this one in the G class. Anyway, it will take long time for this one because you will find mirror which is the same size as the short band paper. And then if you're having hard time with that one, so let me know also. Okay? Question? Nine? I hope I can have my video lecture to you so that I can send on Monday so that you can study the light so that by next week review only. Okay? So it's already time 11:50. I don't want to extend because maybe it will cut already by the GMIT. Let me ask the prayer leader, Jello, please lead the prayer.
Let us pray. Lord, thank you for the lesson today. It's great to find out new things about your world. Help us remember all we have learned today in class. We look forward to tomorrow and all the wonderful things we will be taught. Amen. In the name of the Father, the Son, the Holy Spirit. Amen.
Thank you so much, everyone. And